Let us look at proposition number 27 of book 7 of Euclid's Elements. The proposition says if two numbers are relatively prime and each multiplied by itself make a certain number, then the products are relatively prime. And if the original numbers multiplied by the products make certain numbers, the latter are also relatively prime. A bit tricky to understand. Uh, so let me explain it. Here, we are given two numbers, A and B. They are relatively prime. Now, C is A times A. That means A multiplied by itself gives us C. And A times C gives us B. Similarly, B times B gives us E. And B times E gives us F. So, for example, if 2 and 3, A and B are 2 and 3, let's say. If 2 and 3 are relatively prime, then 2 to the power of n and 3 to the power of n are relatively prime. So from where did this n come? Remember, A and B are relatively prime, 2 and 3, right? A multiplied by itself gives us C. B multiplied by itself gives us E. Multiplied by itself means what? Squaring the number. So A square and B square are relatively prime. But A square is C and B square is E. So that means C is relatively prime to E. Now, next what we are saying is A times C. But C is what? The square of A, which means C is A square times A, which is cube. So D is A cube. F is B times E. E is B square. So F is B cube. So basically here in this proposition, Euclid is taking us through two powers, squares and cubes. And the same logic can be applied to any power. Okay, that is that. So basically this can be written as if GCM of A and B equal to 1, then GCM of A to the power of n and B to the power of n will also be equal to. Okay, so let's see how we can prove this. We are given A and B are relatively prime. C is equal to A times A. That means B and C are relatively prime. How? Because we have already seen in one of our previous propositions that if two numbers are relatively prime and a third number is a product of one of these, then that third number will be relatively prime to the remaining number. So B and C are relatively prime. E is equal to B times B. Again, same proposition we can apply here also. Yes. So that means C and E are relatively prime. Here see B and C are relatively prime. E is the product of one of these relatively prime numbers. That means the product is also going to be relatively prime to the remaining number. That is C. So C and E are relatively prime. Now C is what? Square of A. E is what? Square of B. So we have shown that A square and B square are relatively prime. That is the first part. Now let's take it further. A and E are relatively prime. How? E is the product of the B with itself. So same proposition if we apply, then E will be relatively prime to the remaining number, that is A. So A and E are relatively prime. So what do we have? We have A and C relatively prime to B and E. That means A is relatively prime to BE, C is relatively prime to BE. So let's make sure that we have that. A and B are relatively prime, so A is relatively prime to B. A is relatively prime to E. Similarly, C is relatively prime to E, and C is relatively prime to P. So two numbers are relatively prime to two numbers. Again, one of our previous propositions, which says that if that is the case, then their products are also going to be relatively prime. So A times C is relatively prime to B times C. Now A times C is what? A times C is D, and B times E is what? F. So that means D is relatively prime to F, or we can say D and F are relatively prime. And here D is what? D is A times C. C is what? A square. So A square times A is A cube. So D is A cube. F is similarly B cube. So we have shown A square, A cube and B cube are relatively prime if A and B are relatively prime. That is proposition number 27 of book 7 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share it. That's it for now. Bye.